Hello, my wonderful chemists. Today we are going to talk about stoichiometry with heat calculations. So as you've seen in a lot of our other chapters, we tie stoichiometry into a lot of things. Stoichiometry is calculations in chemical reactions where we can relate one substance to another typically, and usually using the molar ratios, which are the coefficients. And so with any type of calculation, to tie it into stoichiometry, usually the link there is the moles. So somehow moles are going to be involved. So let's take a look at the first example. It says, how much heat is transferred when 9.22 grams of ethane, which is C2H6, in your body reacts with water according to the following equation. So it looks like it's a combustion reaction. We're given the delta H for the reaction. It's negative 1,559 kilojoules. And so they're telling us it's an exothermic reaction. It's releasing that much heat. Now, when they give us delta H for the reaction as written, what that means is that this is for that many moles that are given to us. So this is how much heat is released if you use 2 moles of ethane, 7 moles of oxygen, and produce 4 moles of CO2 and 6 moles of water. So they're asking us how much heat is transferred when 9.22 grams of this reacts. So they're looking for heat transferred, which is the delta H, but they already gave us the delta H, right? So what are they asking for exactly? Well, in terms of ethane, this is how much heat is released when you use 2 moles. We don't want to know it for 2 moles. We want it to know for 9.22 grams. So usually they'll give you the delta H for a different amount than they're asking. Or they'll give you heat for the reaction as written, and also heat for a certain amount, and ask you what is that amount that would give that heat. So let's try to work on this together. So first, we're going to take our grams. So we're given 9.22 grams of this ethane, and we're going to go ahead and convert that to moles. So we're going to put grams here. This is C2H6. Moles here. And the molar mass of ethane is 18 grams per mole. So that gets us 2 moles, but we're looking for joules or kilojoules. We're looking for heat transferred. So we want to get rid of the moles, so we're going to put it here, and we're looking for kilojoules, so we'll put it up here. And this number is telling us that it releases 1,559 kilojoules for every 2 moles. So we're going to write negative 1,559 kilojoules for every 2 moles. We get that 2 from the balanced equation here. So then our moles cancel, and our answer is negative 118 kilojoules. So we release 118 kilojoules for the 9.22 grams. We release 1,559 kilojoules for the 2 moles. So that's the difference there. It's a different amount. Okay, let's look at the next one. It says, how much heat is transferred when 147 grams of NO2 is dissolved in 100 grams of water? And it looks like, it says dissolved, but it looks like there's a chemical reaction happening here. It's already balanced for us. And we have our delta H as negative 138 kilojoules. So this is for 3 moles of NO2, 1 mole of water to produce 2 moles of HNO3 and 1 mole of NO. So we know that we have 147 grams of this, and we have 100 grams of this. We're asked how much heat is transferred total if we use that amount. Well, this looks like a limiting reactant problem. How do I know that? Because I'm given information about both reactants here. So when you do a limiting reactant problem, there's many different ways to do it. You could either start with one reactant, solve for the other reactant, see if you have enough. You could start with both, solve for how much product you'd form, and see which one gives you less, which one limits you. In this case, what I'm going to do is I'm going to start with both reactants and solve for how much heat will be produced. And the one that produces less heat is going to be the correct one, which is going to be my limiting reactant and the correct amount of heat that's released. So I'm going to start with 147 grams of NO2. I'm going to change that to moles. So grams of NO2 on the bottom, moles of NO2 on top. 1 mole of NO2 is about 46.0 grams. And then I'm going to go from moles of NO2 to heat released. And I know I have negative 138 kilojoules, and that's for every 3 moles of NO2. So that gives me negative 147 kilojoules. I'm going to do the same thing for the water, 100 grams of water. Molar mass of water, H2O, is 18 grams. And then I'm going to go from moles of water to heat, and I know it's negative 138 kilojoules for every 1 mole of water. How did I get that? I get it because that's just 1 mole of water here. So this gives me negative 767 kilojoules. So which one's the correct answer? Well, which one's the lower answer? Because it limits me, right? Well, the problem here is that these are negative values. What does the negative mean? It means released. So if I were to use all of my NO2, I would release 147 kilojoules of heat. If I use my water, then I would release 767 kilojoules of heat. So which one's releasing less heat? Well, that's your correct answer right here. It is releasing less heat. So don't let the negative trick you there. The negative just means how much heat is released. Okay, last problem. We have 3 grams of magnesium. When they're burned, we release 75 kilojoules of heat. What is the molar enthalpy of combustion of magnesium? So they don't give us an equation here, so let's write our equation. We're burning magnesium. So take Mg, add oxygen, you would get MgO. And to balance it, you need 2, 1, 2. They tell us that if I use 3 grams of magnesium, I get 75.0 kilojoules released. You can write it as 75.0 kilojoules released, or you can write negative 75 kilojoules. So what are they asking for? They are asking for the molar enthalpy of combustion. Let's think about what that means. Well, enthalpy means heat of combustion. So the delta H when I burn this, right? So the delta H for this reaction. But it says molar. So that means I want the heat per mole. So not just kilojoules, but kilojoules per mole. So there's a couple of ways to do this. Since I want it per mole, I could figure out how many moles are in the 3 grams and take my kilojoules and divide by the number of moles. So let's try that. 3.00 grams of magnesium. Molar mass of magnesium is 24.3 grams. So that is 0.123 moles of magnesium. And I know that I have 75.0 kilojoules. This is 4.123 moles. And so that gives me 607.5 kilojoules per mole. So if I'm given kilojoules and I'm trying to find kilojoules per mole, then I take my kilojoules and divide them by the moles. Pretty easy, right? Let me show you another way to do it. I know that I have 75.0 kilojoules, and this is per 3 grams of magnesium. Well, I don't want it for 3 grams of magnesium. I want it to say kilojoules per mole. So I want to keep my kilojoules, but I want to get rid of that grams and change it to moles. So I'm going to put grams here and moles here so that when I multiply, my grams cancel and I end up with kilojoules per mole. And I know that 1 mole of magnesium is 24.3 grams. So this gives me 607.5 kilojoules per mole. So either way, you can use your units to cancel to get the units that you want. either this way or this way. But if you're given kilojoules and you want kilojoules per mole, you just basically divide by the moles. All right, have a wonderful day. Bye, guys.